What is the magnitude of the largest possible earthquake? The magnitude of energy released during an earthquake is determined by the extent of crustal rupture. Fortunately, it is improbable that we will witness an earthquake with a magnitude of 10. The southern region of Chile had a catastrophic earthquake on May 22, 1960. For a duration of 10 minutes, the Earth experienced such intense seismic activity that individuals found it unable to maintain an upright position. The occurrence of fissures in road surfaces and the structural failure of structures were observed. According to a report by the U.S. Geological Survey, USGS, a person whose story was documented initially had the belief that the seismic event and following tsunami were indications of an escalation in the Cold War leading to a catastrophic nuclear conflict. The seismic event known as the Valdivia earthquake derives its name from the town in closest proximity to its epicenter. This particular earthquake is estimated to have had a magnitude of approximately 9.5, making it the greatest seismic event ever documented, both in the past and now. However, is it possible for earthquakes to increase in magnitude? Say 9.8. According to geoscientists, the response is positive. Nevertheless, the probability of a significantly greater earthquake occurring is minimal. Although it is theoretically possible for an earthquake with a magnitude greater than 9.5 to occur, such an event would necessitate the simultaneous rupture of an exceptionally large portion of the Earth's crust. This rupture would need to occur along a fault that is both exceptionally deep and unusually lengthy. According to Wendy Bohan, a geologist specializing in earthquakes and scientific communication, there exist only a limited number of locations on our planet where such an event may potentially occur. According to Bohan, it is quite probable that a seismic event with a magnitude of 9.5 represents the top threshold of seismic activity that the Earth is capable of producing. The occurrence of an earthquake with a magnitude of 9.8 or 10, on the other hand, is exceedingly improbable. Bohan remarked that while this particular scenario may be advantageous for Hollywood, it lacks realism in the context of the Earth, for which Bohan expressed gratitude. Magnitude is a quantitative assessment of the quantity of energy discharged during an earthquake. The perception of earthquake intensity might vary depending on factors such as an individual's proximity to the epicenter and the characteristics of the surrounding terrain. According to Bohan, an individual standing on loose soil and sand will perceive the same earthquake as being more intense compared to someone standing on solid bedrock. The magnitude of an earthquake is contingent upon the whole surface area of a fault that experiences rupture. The extent of this phenomenon is contingent upon the vertical depth of the fault inside the Earth's crust and the horizontal length of the segment that experiences rupture. There exist physical constraints that impose limitations on the maximum size at which a region can fracture. The subduction zones are characterized by the presence of the deepest faults, where one tectonic plate undergoes the process of being forced beneath another. Upon further investigation, it is observed that at significant depths, the rocks exhibit elevated temperatures to the extent that they become highly heated and malleable, resulting in a flexible rather than brittle behavior. According to the United States Geological Survey, seismic events can occasionally transpire at depths of 500 miles, 800 kilometers, beneath the Earth's surface. However, it is noteworthy that deep earthquakes typically do not induce significant vibrations of the Earth's exterior. However, it is the earthquakes transpiring within the uppermost layers of the Earth's crust, specifically within the upper few tens of kilometers, that pose the greatest threat to human populations. According to Heidi Houston, an earthquake geologist at the University of Southern California, the faults that possess the highest potential for triggering significant and destructive earthquakes are inclined faults located within subduction zones. These faults, referred to as oblique faults due to their non-vertical orientation, exhibit extensive rock surfaces that can become interlocked, resulting in the accumulation of stress and subsequent rupture. According to Houston's analysis, the primary determinant of the maximum earthquake size is the magnitude of the dipping fault plane, which tends to be larger in the subduction zone context. However, there exist constraints on the maximum length of a fault segment that is capable of rupturing. According to Bohan, subduction zone faults do not rupture simultaneously. In general, an obstruction may arise, such as a seamount or a variation in rock type or geometry. which imparts differential stress resistance to adjacent segments of a fault. According to Houston, an additional element contributing to the size of an earthquake is the extent of fault displacement, sometimes referred to as fault slip. Typically, smaller segments of a fault exhibit relatively lower levels of slide compared to larger segments. In seismic events, it is seen that a magnitude 5 earthquake has the potential to cause a displacement of a few millimeters, which is generally insufficient to induce surface rupture. On the other hand, a magnitude 9 earthquake exhibits a significantly larger displacement, estimated to be approximately 66 feet or 20 meters, or even greater. According to Sergio Barrientos, a seismologist at the University of Chile who experienced the 1960 Chile earthquake, NPR reported in 2016 that the seismic event resulted in an expansion of the country's territory due to the stretching of the ground. The earthquake magnitude scale has the potential to mistakenly confuse the distinction between earthquakes of significant magnitude. The scale utilized is logarithmic rather than linear, so each unit increment corresponds to a 10-fold increase in ground motion and a 32-fold increase in released energy. Bohan used the metaphorical concept of fracturing a cluster of spaghetti. If the act of breaking a single strand of spaghetti can be considered analogous to a seismic event with a magnitude of 5, then follows that the release of energy equivalent to a magnitude 6 earthquake would necessitate the breaking of 32 strands of spaghetti. Based on the spaghetti scale, a seismic event of a magnitude of 7 can be analogously represented as the breaking of approximately 1,024 strands of spaghetti. Similarly, a magnitude 8 event corresponds to the breaking of approximately 32,768 strands, while a magnitude 9 event is comparable to the breaking of approximately 1,048,576 threads. This illustrative instance demonstrates that the disparity in energy released between an earthquake measuring magnitude 8 and one measuring magnitude 9 is significantly greater than the disparity between an earthquake measuring magnitude 5 and one measuring magnitude 6. Hence, increasing the magnitude of an earthquake from 9.5 to 9.6 necessitates a significantly larger region of fault rupture compared to the transition between magnitudes 5.5 and 5.6. According to Houston, the scientific community continues to engage in a scholarly discourse on the precise magnitude of the 1960 Chilean earthquake due to the presence of measurement uncertainties. However, in order to emphasize the significant disparities in the magnitudes of seemingly minor numbers within this range, Houston stated that a magnitude 9.5 earthquake is more than twice as powerful as the second largest recorded earthquake, which had a magnitude of 9.2 and occurred in Alaska's Prince William Sound in 1964. There exist planetary disasters that possess the potential to induce significantly larger scale seismic events, such as the hypothetical scenario of an asteroid collision. Certain experts hypothesize that the asteroid impact that occurred at the end of the Cretaceous period, around 6 to 6 million years ago, resulted in seismic activity of considerable scale. However, accurately determining the specific magnitude of these earthquakes is a challenge. According to Houston, it is plausible that Earth may experience such a catastrophic event over the course of billions of years. According to her statement, the probability of an event exceeding a magnitude in the mid-9s during an individual's lifetime is quite minimal. According to recent research conducted in 2022, the largest seismic event in ancient times, as inferred from geological data, occurred in Chile around 3,800 years ago. This earthquake is believed to have had a magnitude of approximately 9.5. According to Bohan, the significance of an earthquake's deadly force, particularly for humans, does not just depend on its scale. The occurrence of smaller seismic events has resulted in several fatalities, mostly due to their impact on densely inhabited areas and structures susceptible to structural failure. While the earthquake in Chile, measuring 9.5 in magnitude, resulted in approximately 2,000 fatalities, the seismic event in Shanxi, China, with an estimated magnitude of 8, is believed to have caused the demise of approximately 830,000 individuals in the year 1556. The year 2005 had a seismic event of magnitude 7.6 that resulted in an estimated fatality count of 79,000 individuals in the region of Kashmir. Similarly, in 2010, a seismic occurrence measuring 7.0 on the magnitude scale caused the loss of nearly 220,000 lives in the nation of Haiti. The 1994 Northridge earthquake, with a magnitude of 6.7, resulted in the loss of 57 lives, inflicted injuries upon numerous individuals, and incurred significant financial losses amounting to billions of dollars. This event was particularly impactful due to its occurrence in the densely populated region of Los Angeles, despite the fault responsible for the earthquake having gone unnoticed before to this incident. According to Bohan, there exists a considerable number of potential faults that possess the capacity to generate earthquakes with significant destructive consequences. However, people tend to primarily focus on the larger scale phenomenon. As Barack Obama says, all across the world, increasingly dangerous weather patterns and devastating storms are abruptly putting an end to the long-running debate over whether or not climate change is real. Not only is it real, it's here, and its effects are giving rise to a frighteningly new global phenomenon: the man-made natural disaster. You can suggest topics you want to see next in the comments section below. Please subscribe to Weather Collapse if you want to know more, and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.